So how do we interpret this little experiment that we just saw? Well, we know that that glass rod, when you rub it with silk, actually acquires or has a net positive charge, and that plastic rod that we rubbed with wool will have a net negative charge. And because of that, these two things, when they attract each other, we see they attract because they have unlike charges or different charges. So anytime you have things with opposite charge, for example, positive, negative, they will have an attractive force. Whereas things that have the same charge or like charges, so positive, positive, or negative, negative, those will have repulsive forces. So opposite charges attract, and like charges will be repulsive, or they will repel each other away from each other. If I do have two rods, kind of looking at experiment number 4, as I get the rods further and further apart, I see that the force between them actually decreases. And because that force decreases, we know that this is some sort of action over a distance. The second thing that we can look at is the strength of the force. It is greater for rods that have been rubbed more vigorously. We'll talk about why in a few slides here so you can see that. This same experiment number 4, like the gravitational force, and if you remember the gravitational force, the equation for that is this equation, big M times little m, all over the distance, or actually just the distance between them squared. So I know that as I get further and further apart, because this number on the bottom is getting bigger, I know that that force is getting a lot smaller. And then the greater the charge on the two objects, because we have big M's in here, if we replace those with charges, and we're going to do that later, we're going to call this Q1 and Q2, that's the amount of charge on each one. We see that the more charges or the more things you have on top, the bigger the force is between the two objects. For the first quick check, I have a charged glass and a plastic rod, and they're both held by threads. So here's my glass rod. Glass rods typically have that positive charge on them, so we're going to put G here. And then I have another rod, and this rod is plastic, and it has picked up a negative charge. And it says that an object will attract a glass rod. So we know that this object most definitely has got to have some negative charge in it. Question is, does it have to have an excess negative charge? If we hold this object near the plastic rod, what will it do? Okay, it's either going to attract, repel, not affect the plastic rod, or it might either attract or repel it, kind of depending on what's going on. So for this one, we're really going to look at the answer here first, and we're going to see that it could be either A or B. If it attracts the plastic rod, we know that it would have to be neutral. Okay, if it was neutral, then it would be able to attract that plastic rod. It would repel that plastic rod if it had a negative charge. So it could be either one. So there's really just not enough information for us really to be able to make a good informed decision about what's going to happen. Here's the next quick check. This is 20.2. A rod attracts a positively charged hanging ball. We want to know, is the rod positive, negative, neutral, either A or C? So is it positive or neutral? Or is it either B or C, negative or neutral? So if it is attracted, we know that there's got to be some sort of negative charge somewhere along the rod. Question is this rod neutral? In other words, does it have 3 positive and 3 negative charges on it, just that these charges tend to be on one side and these has an kind of a little bit of a positive charge on the other side? That would make it neutral. Or is it that this thing is got an excess number of negative charges, and so therefore it would be negative? So it looks like our answer here has got to be letter E, which it is, either B or C. So it can either be a neutral rod, which may have a little bit excess on one side versus the other, but the same number of charges, or it could have just more negative charges on it. So that is your answer. A charge diagram is a really useful item. This just gives us a picture of kind of all the charges that are on an object. So positive charge, if I have an excess positive charge, you'll see it as pluses. Excess negative charge would be negative. And then the more pluses or negatives that I have will kind of tell us how strong that charge actually is. So that tells us kind of what's going on. If I look at the next one, here we're going to have experiment number 5. I've got a neutral uncharged hanging rod, and I have a uncharged piece of wool, and I'm going to rub the wool on that charged rod. And when I do that, I notice that they attract each other. Because that wool attracts the rod, the wool must have some sort of excess positive charge. So we're going to go ahead and put positive charges on here, and then this plastic rod must have some sort of excess negative charge. If that's true, then we know that they will attract, because opposites, we know, opposites attract. And that's kind of what should happen in experiment number 5. And that gives you both the what happens as well as the interpretation. This talks about just a little bit more. When we rub that rod with wool, not only does the plastic rod have a negative charge, the wool itself will have a positive charge. And so a neutral object is not something with no charge. Okay, if I have, before I rub that wool on something else, we know that it's got both positive and it has negative charges. So as long as it has equal amounts of both, then we would say that that thing is neutral. So this would be before we discharge it or we charge something else with that thing. An object can be positively charged if we have more positive than we do negative charge. And same thing with a negatively charged object. It's got more negative charge than it would a positive charge. And we saw that with the wool and with that plastic rod. So let's take a little bit more of a picture of this, kind of look at what's going on. So here they're initially neutral. And because they're neutral, they have the same number of positive and negative charges on each one. So you can actually count them and see that. If I rub the two together, the negative charge will actually move from the wool onto the rod, and we'll end up with more negative charges now on the rod and more positive charges on the wool. And we can go through and see that we have 3 positive and we have 6 negative. So the overall net effect here is we have 3 negative charges on the rod, and now we have 3 positive charges on the wool. So we're just showing the excess in this picture, and in this picture we're showing the total charges. Typically what we want to do is show just the excess charges, and that kind of helps us see what charge the object is overall. Law of conservation of charge, just like the law of conservation of energy or a momentum, you can't create or destroy charge. You can only transfer it from one place to the other. So if we see a large amount of positive charge somewhere, there must be a large amount of negative charge somewhere else, so that the net charge does not change within our system. So if we start with something neutral and then all of a sudden if something has a large positive charge, something else must have a large negative charge. This is the charge model. This is just part 1, frictional forces. So if I rub something on something else, I can transfer charge from one thing to the other. There's a couple different types of charges, positive and negative. And like charges will will repel. And we know opposite charges will attract. And we call these forces electric forces. The next part of this model says the force between two objects is a long-range force. Okay, and so it will increase as we get two things closer together, and it will decrease as they get further apart. We did talk about neutral objects having an equal mixture of positive and negative charge, and the rubbing process charges objects by transferring charge. Okay, usually from one to the other. The objects acquire equal but opposite charges, and that leads us into charge conservation. We cannot create nor destroy charge. And that's the end of the first part of what we've looked at.